Moving to our sample problem number 2. So mo itong given na ay car, na ay jeep that so na ay jeep diri and then na ay hill diri on this side. So atong conditions need to get the maximum speed, again maximum speed gyapon diri, enough nga pag mo agi siya over diri sa crest diri sa hill. So ang crest is mo na siyang point nga nag-change na ang slope sa hill. So mo na siyang sa to pa kinatumyan or kinatung-an. So pag agi niya diri enough nga dili mo lost contact with the road ang sakyanan. So di siya murag muuntol. So enough lang gyud siya nga butang nato mura siya mulutaw, but ang ang tires niya is still on the still in contact with the road. Okay, so ang atong gibuhat diri, since this is the car, we neglect the size of the car, we analyze it like a particle. So this is our rule in analysis sa particles. So whereas the maximum speed it can travel. So unsa may atong buhaton diri? So again, we draw an FBD or the free body diagram. Since naman tay tulo ka component, di ba, sa particle nga moving in curvilinear motion, we have the normal, the tangential, and the binormal component of the particle. So kung ato ang tan-awon diri, unsa may naa nga component nato diri? So since iyang movement is paingon diri, and then we have here the radius. So we have the normal acceleration here. So sa ato pa, on this axis we have the normal axis or the normal component. Wala, is the normal axis. And then since ang direction of motion is on that side, so at this point sa crest, this is our tangential component or the tangential axis. At oscillation is on that side, and then we need to get the velocity. So if we draw the FBD of this particle, so what do we have? We have the weight. This is equal to the mass times the gravitational acceleration. We also have the normal force of the object. Again, unsa pa may gikuha, so wala nang tay gihatag lain, no, wa tay giingnan og friction or anything. So natay normal acceleration there, and then we have the tangential acceleration on this side. Sa ato pa naa siya reverse effective force along the tangential component on the left side. And what else? No, the acceleration is not upwards di no. So the acceleration for this motion, this is a vertical motion, is downward. That is the normal acceleration of this component. So sa may buhaton nato para masolve nato si velocity. So again, sa pinakadali gyud nato, no, we know that the normal acceleration is equal to v squared over rho, and then we have the rho, which is 250 feet. So mas dali if we sum forces along the normal axis than the tangential axis. Okay, so if we sum moment along the normal component, that is just equal to mass times the normal acceleration, or equal to mass times v squared over rho. Remember, this is in imperial units. Sa ato patong gravitational acceleration is equal to 32.2 foot per second squared. So tong forces along n, we have the normal force, and then we also have the weight of the car is equal to the mass times v squared over rho. So unsa may buhaton na to ani so unsa may sign notation na to ani, the n is upward man and then the weight is downward. So actually we can say that positive ang downward. It is because this is the direction of the normal acceleration. Okay, so if that is the case, ang normal force na to will be negative, and then the weight will be positive. Is equal to mass times v squared over rho. Now the thing is, ang gingon diri is maximum speed that it can travel, so it will not lose contact with the road over the crest. Kamati ko man na if magsakay gani mo Ferris wheel, di ba? And then paingunay na mo sa ibabaw. If kusog kayo ang Ferris wheel, murag ma-feel ninyo nga mura mo mulutaw, di ba? So, ang ato mong gipangay diri sang maximum velocity man sa car nga mura siyag mulutaw but dili siya mo hawa yang ligid along the road. So, kung mura siyag mulutaw sa ato pa na walay ingon nga mura gibaton nga force ang surface on this side. Sa ato pa, zero si normal force. Munang sa inyong module, ang gibutang ra nga force is just the plain weight. Okay? So, ang weight nato that is just equal to mass times the gravitational acceleration, 32.2 foot per second squared, that is equal to, so we don't know the mass, so we don't need to know the mass because with the mass or without the mass, makancel naman gyapon ang mass, and then we have the v squared over the 250 foot. Makancel cm, we have v squared is equal to, so we just cross the 250 there, 250 times 32.2, that is equal to 8,050, and then we extract the square root on both sides. So our maximum velocity, just enough, na dili mo lost contact ang car, maximum gid siya velocity, so muna atong zero ni because enough lang gid siya nga pag abot niya diri nga mura siya nilutaw pero wala siya ni biya diri sa surface. So the maximum velocity just equal to square root of 8,050, that is just equal to 89.722 foot per seconds.